Okay, now we are on square roots and cube roots for this lesson. Okay, squares and thing. Okay, as per last lesson, okay, we have already talked about, index notations, correct? What are index notations? Can somebody remind me?
Three dots thing. Three dots is therefore. What the dot? Yeah, it's to make words shorter.
It's a little number.
What does it mean? Three dots is for triangle. Opposite triangle. Three dots is different from triangle.
6 times 6 times 6 then it's like 6 something.
Opposite triangle.
Use the proper terms, okay? There's a reason why I'm only writing what you're saying. This is what you're saying,
Form a triangle using 3 dots.
Abbreviate, okay? Abbreviate multiplication. Example? No, okay. You were saying? Huh? Form a triangle using 3 dots. Is that index notation?
No.
Oh no! This means last week's lesson wasn't effective.
The power of 5 or something like that.
Okay. So as our friend said, it's 6 times 6 times 6. We want to make it shorter, right? So what's the answer here? 6 cubed or 6 to the power 3? Yes. Huh? So that one is this one. Okay? This is therefore. Okay, don't tell me 3 dots. You tell me 3 dots, I write you 3 dots like that. You tell me triangle, I give you triangle like that. You tell me 1, 2, 3, I write you 1, 2, 3. No. Okay, the idea here is I want you all to be aware of what you're saying in mathematics. Okay, we want to be more precise in terms of the way we communicate mathematically. Okay, don't tell me just 3 dots, triangle. I'm literally writing what you're talking. Okay, so there's a lesson here. There's not. I don't think I write this for fun. I write this to let y'all be more aware. Okay, so we learn from it. Okay, when you talk about index notation, we're actually looking for a short way to abbreviate multiplication of many of the same numbers. So 6 times 6 times 6 is 6 to the power of 3. Now this is very different. Let me point it out to you. This is very, very different from 6 plus 6 plus 6. What is this?
6 times 3 times 6. 6.
It's 3 times 6. Very different from 6 to the power of 3. Okay? Do not mix them up. They are two very different things. 6 to the power of 3 is what? It's a very big number, right? It's about 216. Okay, the value of 6 to the power of 3 is 216. The value of this is 18. Think carefully before you write. Both are very, very different things. Let me remind you. Yes. Go. Okay, so that's index notation. Now, we're going to dive down into just squares and cubes for this part of the lesson. Okay, so we know that when we say 5 square, when we say the word 5 square, what we're actually referring to is 5 to the power of 2, right? Or 5 square. Or in the sense, this is 25, correct? And 25, we also call this we also can call this we call this number here a perfect square. Okay, what are some examples of perfect squares?
What is a perfect square?
What is a perfect square? Perfect square means when you square a number and this value comes from this kind of notation. For example, 1 square is equals to 1, right? What's 1 times 1? 1 is a perfect square. Then we have 4, which is made of 2 squared. This is also a perfect square. 10 squared or 10? 10 squared is equals to 100. This is a perfect square. Okay, why? Let's say I have 4.1 square. Is this a perfect square? The value, this is not a perfect square. Perfect square must be a whole number. Okay, are squares of whole number. They are the squares of whole number. So this makes this a perfect square. 5.5 is not a perfect square. It must be a whole number. 3.2? 3.2 means 32? Okay, or just 3 squared. 3 squared is 3 squared equals to 9. Is 9 a perfect square? 9 is perfect square because it's made up of a whole squaring a whole number. Yes, sir. Kaiser and Jordan. Is Jordan here? Okay. Is Jordan here? Who is Jordan? Oh, then who's Kaiser? Kaiser is the other class, is it? You are Kaiser. Kaiser is the other class, right? Kaisheng, right? Yeah. Okay. So there are a few perfect squares. 1, 4, 9. Okay. Can you tell me what's the next perfect square here?
4.
4 what? 4 square, right? So 4 squares equals to 16. 16 it becomes a perfect square. Now we have 5 square here. We also have 6 square, right? 36. And we also have 7 square. Okay. Yeah, as long as the number here I square a whole number, this makes this a perfect square. There's a lot. This is a perfect square because later we'll come to that. Why? Because is there a way to derive this number if I give you this value? That's the question here. Okay, but later we will look at it. Okay, so the perfect squares, if you look at your notes, perfect squares are squares of whole numbers. Okay, perfect squares are the squares of whole number. This is the whole number. This thing here is the whole number. Okay, when I square a whole number, this is a perfect square. Okay, this is just definition. I'm just setting the ground foundation. Okay, now same thing. Now let's go to that. So let's say I give you a number. Let's say it is 64. How do we tell this is a perfect square? Square root. What is square root?
You have more than 2 multiples.
More than 2 multiples? How do I tell that this is a perfect square? 8 times 8. You all know it's 8 times 8. But that means you all are using what you all know, which is factors, right? You use factors to help you decipher. Okay, you are using factors. But is there a way not to use factors? Okay, which one of your friends said is square root. But what is square root? Square root is the reverse of squares. Okay, so we have 5 square is equals to 25. If I apply square root is the sign is like that. I square root the perfect square, it will give me 5. Okay, can you take out your calculators and you can try on your calculator. There's a square root function. Always bring calculators as well. Okay, as I said, calculator is a must. Okay, if you square root a number and you get a perfect whole number, I said, hey, listen. Okay? If you square root a perfect square, you will always get a whole number. Now you try square root this number, 88.
3. Why not 3?
Chinese New Year coming, 88. What do you get? Do you get a whole number? No, you get a long decimal, right? This means that 88 is not a perfect square. Okay? Now try square root 81. It's equals to 9, right? Okay, what else? Square root. Try square root 2. Square root 2 is a nice number.
Why not 3? I get 1.44478.
Okay, 1 point. Hey, you realize that these are not perfect squares. Perfect squares, when you square root them, it will give you a whole number. Square root 3. You try? Okay, now square root 2 is going to be a special number in mathematics. It's a symbol of, actually it has something to do with triangles.